Okay. And we're going to start with, hopefully I can find it. This is not what we're starting with, but that's what okay. So we're going to start with solving quadratic equation sets. So you should have your 3.2 notes and possibly 3.3 notes. If we get through that today, you should have had the notes packet from the last time I saw you. So get out your notes packet, 3.2 notes, 3.3 notes, okay? Starting with quadratic sets. So again, let's see. All right. So what can we do? We can find our pen that we have lost. Okay, so what are we supposed to be able to do with this is essentially solve a quadratic equation. We can solve a quadratic equation. So there's essentially a couple of different formats of quadratic sets. So essentially anything that's quadratic has a square in it, okay? So standard set where it's all expanded, like 4x squared minus 6x minus 3. A squared vertex set where the square is inside parentheses, parentheses x plus 3 quantity squared, or full on factored form, x plus 4, x plus 7. When you're solving quadratics, this is 3.2 notes. Ethan, I think you just entered the room, so we're on 3.2 notes right now. We're just starting. A zero of a function is something where you're setting your equation equal to 0, okay? So what that means is right here, we're saying our equation, and we're putting it equal to 0, all right? Zero product property says we have two numbers and we multiply them and we get 0. So if we're getting 0 for our answer like this, AB equals 0, then that means to get 0 as a multiplier, either your first value had to be 0 or your second value had to be 0. And when you're dealing with quadratics, that's the main thing we are using in order to help us figure out how to solve this kind of equation, all right? So we're essentially finding zeros. So the key idea here is that it needs to be in factored form. So if we've got factors, then we can say, okay, we've factored it. We know how to do this already because we've done this in the last unit where we're doing tons of factoring. So now we're saying, okay, so we want to find the zeros. What's their step 1? So finding our zeros. Okay, step 1, you want to set equal to 0. So essentially right there, I'm setting my equation equal to 0. You cannot solve an equation directly that has both a squared and an x. So basically I got an x squared set and an x set. I cannot solve that as a direct set because x squared and x don't combine nicely like that. So I need to get it somehow in different format. So it's not with x squared and x at the same point in time. And the way I do that is my favorite thing to do in the whole entire universe, factoring. So 2, I've got a factor, okay? And you want to factor always if possible. Not everything factors as we learned in the last unit. So we cannot always factor, but if we can, that's what we want to do. Then essentially what I have is something equal to 0. And I have 2 factors. So here's my first factor, x minus 8, and my second factor, x minus 3. And then from the 0 product property, so the whole key idea here is that 0 is really important because then what I can do is say, you know what, if my answer is 0, that means one of my factors has to be 0. So I can set each factor equal to 0 and solve it. So that's step 3. Set each factor equal to 0, and then your solutions. Okay, so it's writing that as a point set to be clear that essentially you are finding x and the y value is 0. So you're finding, when it says find the zeros, it's saying set your equation equal to 0 and solve it. So you've got two solutions, x equals 8, x equals 3, or you can write them as points as they did on the left, 8, 0, and 3, 0. So on your second example, example 2, it's giving us our sets, our instructions, here's what we need to do, and then we're going to practice, okay? So if we have an equation set, first thing, get it equal to 0. However, we have to do that, manipulate it, whatever. So 4x squared minus 4x minus 15 is equal to 0. Then, if possible, I want to factor. So now I need to do all my factoring sets. So let's see, negative 60, negative 4. That's got to be negative 10 and 6 to make that work. Check, check. And grouping or box, however you want to do it from there. So let's see, 4x squared minus, okay, so I'm just doing factoring, okay, so minus 10x plus 6x, that splits up the minus 4, grouping, first 2, second 2, let's see, 2x, 2x, 2x minus 5 left over, and 3 pulls out of that. So GCF 2x minus 5 pulled over. All right, so my factor set, so now I've basically got my factors. So now my factor set is 2x minus 5, 2x plus 3, and remembering that I actually did have an equation of 0, so I factored up there, but what I need is that 0 to come down here. So now here's my equation, okay? I'm a little bit short because I should be here. I just finished factoring, so that's what I've been doing. Now I need to set each factor equal to 0. So now my possibilities are that 2x minus 5 could be 0, or 2x plus 3 could be 0. Micah, we're just working our way through the second example on 3.2 notes, so quadratic sets. Katie, that's where we are as well, so you should have your notes packet. So here's our equation, we factor it, we set each factor equal to 0. Then once we've done that, essentially possible solutions are 2, so we solve each set. So adding the 5, 2x equals 5. Dividing the 2, my first possible solution is 5 halves. Okay, subtracting the 3 on the other one, on the one on the right, so 2x equals negative 3. Dividing the 2 again, x equals negative 3 halves. I want you to make a note that fractions are entirely possible on these. Okay, so that is my solution set. Or if you want to write it as a point set, x would be 5 halves, y would be 0. X would be negative 3 halves, y would be 0. Either one is adequate. Okay, so that's the factoring process. If you can factor it, you factor it, set each factor equal to 0, solve the factors, list the solutions. So we did one where we kind of wrote down the steps, and the second one where you have the steps listed, and then this is what we're working on now. Here's your steps listed. Here's the process you need to go through, okay, in order to get this one correct. All right. I was saying a couple minutes to work on these, see if you could do them. So zeros using factoring, okay? Essentially, I have two factors here. This one's a little confusing because I've got this x out in front, number one. So that's one factor. And essentially, it's negative x equals to 0 because that's my first step is basically get rid of this x, put 0 there. And so if you have a factor that's just x, that means x itself can be 0 because 0 multiplied by anything is still 0. The other possibility is x plus 7 equals 0. So x equals negative 7. So the idea is if I put either of these values into my original equation, I will return a value of 0. Okay. Next one, it's already factored. If it's already factored, don't multiply it out. Don't do all this work because you've already got nice little sets of factors on number 3 already in parentheses. So all you need to do is put a big 0 there. All right. And then what you have is x plus 13 equals 0. X minus 4 equals 0. Set each factor equal to 0. So x would then be a possibility of negative 13, subtracting 13 from both sides, or x equals 4, adding 4 to both sides. And those are your solutions for number 3. Okay, on number 5, we have a lot of these. On number 5, we need to factor that first. So 0 equals, let's see, multiplying to positive 6, adding to negative 7, x minus 1, x minus 6. Those are my factors that work for that. So then x minus 1 equals 0, x minus 6 equals 0, x equals, so each factor equal to 0, x equals 1, x equals 6. Okay, last one, same idea. 0, factor that, x minus 2, x plus 1. Multiplying to negative 2, adding to positive 1. So factoring, setting equal to 0. Make sure, like this here, when you have, again, an x squared and an x together like that, you cannot solve for that directly because you cannot isolate x squared and x together because they don't combine. So you have to factor it so you can basically isolate it down. So I'm isolating x's. Since factors are equal to 0, then that's why I can essentially do the x minus 2 equals 0, x plus 1 equals 0, each factor equal to 0. So x equals 2, adding 2 to both sides. On the left-hand side, x equals negative 1, subtracting 1 from both sides on the right-hand equation. And those are my two possible solutions. So generally, quadratics are going to have two solutions. Either you get two solutions, most of the time two solutions. If you don't have to get a solution though, and we'll look at that next. So generally though, these that are factorable, if it factors, you will always get two solutions. I'm going to look at 9. 0, and that is a GCF factoring, which is why I'm doing this. So when you see a different type, sometimes it will throw you off. So always checking for the GCF. This case, the GCF is for x, and leaving me with x minus 3 inside my parentheses. Those are actually factors because I'm saying 4x is a multiplier. So it's just not got a plus or minus on it, okay? So what I have then is 4x equals 0 for my first factor, x minus 3 equals 0. Notice on this 4, it's multiplying. 4 times a number equals 0. When that happens, that means that number has to actually be 0 itself because 4 times that value is actually 0. Okay. Second one, adding the 3 to both sides, we're going to get x equals 3. And there's my factor set. Okay. So hopefully fairly straightforward. On 10, 10's a little different, and the reason why is because I have an x squared term and no x term. So this does factor difference of perfect squares. So there's two strategies I can use on this one because it has just a single x value and it's just x squared. I don't have x squared and x in the same problem set. So factoring 0 equals 3x plus 5, 3x minus 5. So I should see a difference of squares. So plus and minus, perfect square set. So 3x plus 5 equals 0. 3x minus 5 equals 0. Adding, subtracting the 5 on both sides, dividing by the 3 on both sides. This one on the left, I'll get -5 thirds. This one on the right, I'll get positive 5 thirds. So plus and minus 5 thirds is this particular set. Let's see, I've got multiplying to 30, adding to 17, so 2 and 15. So grouping or box, let's see. So let's see, 3x squared and 10, 2 in the middle, 2x and 15x, because I did the last one grouping, so I'll do this one box. Factors, let's see, that's got to be 3x and x, 3x. 3x times something is 15, x times something is 2. So that's got to be 5. On the top, that's 2. And then I'm checking. The check is if 5 and 2 actually multiply to 10, which they do. So check. So those are the factor sets. So this is essentially what we did in the last unit, but now we're not done yet, okay? So we've done all this work, but we're not finished because our goal is to get equal to 0. So 3x plus 2, first factor, x plus 5, second factor, equal to 0. 3x plus 2 equals 0, first factor equal to 0. X plus 5 equal to 0, second factor equal to 0. Solve each one. So x equals -2 thirds, subtracting the 2 and dividing by the 3. And x equals -5, just subtracting the 5. No division needed there. So there are my two answers. So it's right in there in your notes if you can't remember it. So what do we use to solving it? Here's the formula, here's the workout, okay? First, whether you do it in your head or on paper, you need to label your numbers, okay? They're in order, so, okay. So these notes need to be fixed. Let's fix them right now. Fix. We're gonna pretend like you didn't see this. This is 14. This is 13, otherwise it doesn't work, okay? So A is 2 still, B is -14, and C is -13. Otherwise, my numbers that are all over there already done are not going to work. So they were backwards. They were backwards. So bad math right there. So anyway, fix up top because too much work otherwise. Okay, so B, let's do it. Now B is -14. Okay, A is 2, C is -13. Okay, so I just fixed the problem because I want it to work out right. Then from there, so essentially, what are your steps? Substitute in your actual numbers. Step 2 is simplify forever. Forever. Okay, so because you got to keep simplifying. This is all simplify. Because you got to keep going and going and going until essentially you have it as far as possible. And then we're actually not done because we can still actually reduce out of 2. So your final answer here is 7 plus or minus 5 root 3 over 2, because these all have a common factor of 2. Okay, when you're reducing out, make sure you're reducing out or 2 times 7 plus 5 root 3 over 2 times 2. And then that reduces out as a common factor of 2. Remember, when you're reducing out, it has to reduce out as it has to reduce out through distribution, because division and addition are different levels. So you can't just reduce the 14 and the 4. So you can't just reduce these two. I know that's very tempting. Just say no. That division of 2 has to go through the 14 and also through the 10 because it's plus or minus. Okay. So that is actually my final answer. And then that is actually X as well. So what I'm saying is those are my two X values for my solution set. Okay. I'm going to stop here for, let's see. All right. So we have some practice problems. Let's just practice on, let's just do the top 3, 1, 3, and 5. Quadratic formula. I know you guys are thrilled. So A is 1, B is 10, C is negative 20, and then essentially it's just a lot of craziness. Be careful, don't put the X's in there, okay? Quadratic formula is X equals, so you only use the actual coefficients, not the numbers, not X. X is not part of it. Don't stick X in there, it'll mess you up. You're looking for a solution, not another equation. So let's see, what do we do? Negative B, so negative of 10 plus or minus the square root of 10 squared minus 4 times 1 times negative 20 over 2 times 1. And then simplify, simplify, simplify forever. So negative 10 plus or minus 100 plus 80, 180 over 2. All right, 180, I need to simplify that. 180, 18, and 10. So I'm going back to old school stuff. Let's see. So 2 is a pair, 9 is a perfect square.
Can you hold on one sec?
Yeah.
I'm a little fast, kid, thanks.
Am I running through? Okay, should I start over? Are we okay?
No, it's okay. Let me just copy it down.
Okay, I was talking fast. I tend to do that. I will slow down because I know I start to babble. Okay, so essentially the idea is that I get my coefficients, 1, 10, negative 20. I feed them into the formula. So negative of B, negative 10, B squared, underneath the square root, B squared, which is 10 squared, minus 4 times A times C. So minus negative 4 times 1 times negative 20. And then I kind of did this part together. So essentially, it was sort of like, okay, so that's, in my head I did, okay, so that's 100, negative 4 times negative 20 is positive 80. So 100 plus 80, that's how I'm getting the 180, okay? All right, so I'm here, and now I'm continuing to simplify. So now essentially what I need to simplify is this square root. So I've got the square root of 180, and I need to simplify that as far as possible. So that's how come I'm coming over here and doing a factor tree, all right? 180 is 18 times 10 because it ends in 0. 18 is 9 and 2. 10 is 2 and 5. From here, I'm seeing 9 itself is a perfect square, and then 2 is a pair. So, and then what is stuck inside is the 5 because he has no friends. He can't get out of the square root. So right here, I'm at negative 10 plus or minus, and I essentially have 3 times 2. Square root of 9 is 3, and 1 pair of 2s, right? Square root of poor old 5 is still stuck. And then all over 2, that's where I'm at, okay? So now, again, continuing to simplify, I see I have a common factor of 2. 10 divides by 2, 3 times 2 divides by 2, and obviously 2 itself divides by 2. So I'm going to go through and essentially divide through by 2. So dividing by 2, dividing by 2, dividing by 2. So dividing through by 2, that notation is pretty messy, but that's what I'm thinking about. Okay. So my final answer, -10 divided by 2 is -5. 3 times 2 divided by 2 is 3. Square root of 5 is still where it is. And then all over 1, so I don't write that because it's just 1. And that is my final answer, okay? And that is X. So that is your solution set